In this video, we're going to take a look at the quadratic formula. We can use the quadratic formula to solve any quadratic function to find its zeros and solutions. Only polynomials that are factorable can be solved by factoring. Only polynomials with no middle term can be solved by using the square root method, which is what we learned in our previous video. But all polynomials can be solved using the quadratic formula. The quadratic formula states x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The solutions can be found by plugging in the coefficient of x squared in for a, the coefficient of x in for b, and your constant term in for c. So we'll take a look at our first example. This is find the zeros of f of x equals x squared minus 3x plus 1. First, we have to identify the a, which is the coefficient of x squared, so that's a 1. We need to identify the coefficient of b, which is negative 3, and the constant term c, which is 1. Then we just plug in, and it's super important that you plug in carefully and follow your order of operations. So we start by plugging in our negative 3 for b. Notice there's a negative sign out in front already. So negative 3 will turn into a positive 3, which is what you see here. Under the radical, we have negative 3 in parentheses squared. Negative 3 squared is going to be 9 minus 4 times 1 times 1. 4 times 1 is 4, times 1 again is 4, so 9 minus 4 is 5. That's what you see under your radical here. 2 times 1 is 2, so that's the bottom. So because I can't take the square root of 5 and get a perfect square or a whole number, I'm going to just leave it as the square root of 5. And you'll see two answers, and we learned this in our last video. When you take the square root, you get the positive and the negative value as an answer. So we have 3 plus or minus the square root of 5 divided by 2 as our answer. Or you can put that into your graphing calculator and get your decimals there. This is obviously rounded to the nearest hundredth. You can really break this answer up into 3 plus the square root of 5 divided by 2 and 3 minus the square root of 5 divided by 2. And that's how you would type it into your calculator as well. So let's see if we can put it into practice. We've got f of x equals x squared minus 6x plus 5. We always want our equation solved for 0 when we're using the quadratic formula. So this one we can just replace this with 0. All right, we've got a, here's b, there's c. So our formula says the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of this divided by 2 times a, which is 1. Negative 6 is just going to be a positive 6 plus or minus. Under the radical, negative 6 squared is 36. Negative 4 times 1 is negative 4. Negative 4 times 5 is negative 20 over 2. All right, we'll keep simplifying. Our next step, I'll put that in blue. I've got 6. Oh, I thought it was blue. There we go. 6 plus or minus. 36 minus 20 is 16 divided by 2. So we have 6 plus or minus the square root of 16 is 4 over 2. So we have these two little problems to solve. We've got 6 plus 4 divided by 2, and we have 6 minus 4 divided by 2. If we work on that first one, 6 plus 4 is 10 divided by 2 gives you 5. We work on our second one, 6 minus 4 is 2 divided by 2 is 1. So we get 2 whole numbers there. If you were to type this into Desmos, you'll see that it crosses the x-axis at 1 and at 5. All right, let's try our next example. opposite of b plus or minus the square root of b squared minus 4, oops, that's a square, minus 4 times a and c, all over 2 times a. Okay, we'll start simplifying. Negative 7 is just 7, plus or minus. Negative 7 squared is 49. Then we have negative 4 times 4, that's negative 16, times negative 2 again. It's going to give us a positive 32. Over 2 times 4 is 8. Alright, our next step, again, I'll put that in blue. So we're over here, we've got 7 plus or minus 81 over 8. The square root of 81 is 9, or plus or minus 9. Plus or minus regular old 9. There we go. Over 8. So we have 2 problems to solve. 7 plus 9 over 8, and 7 minus 9 over 8. 7 plus 9 is 16. 16 divided by 8 is 2. 7 minus 9 is negative 2. Negative 2 over 8 you can simplify to be negative 1/4. So you might end up with a fraction 2 as an answer. Go ahead and pause the video and try the next 2 examples. Be careful on this example. First, go ahead and set your equation equal to 0, and then apply the quadratic formula. Okay, we'll take a look at our 2 practice problems. For our first one, we ended up with the square root of 13 under the radical, which cannot be simplified, so we broke it into 5 plus radical 13 over 2, and 5 minus 13 radical 13 over 2. We can get the approximate value by plugging all that into our calculator. We get x is approximately 4.30, and x is approximately 0.70. For the last one, we had to set our equation equal to 0 first, and then start plugging into our formula. We'll get negative 6 plus or minus the square root of 108 divided by negative 8. I chose to simplify my radical and get 6 radical 3. So our answers are negative 6 plus 6 radical 3 over negative 8, and negative 6 minus 6 radical 3 over negative 8. Plugging those into the calculator, you'll get x is approximately negative 0.55, and x is approximately 2.05. The last part of our lesson looks at what's called the discriminant. The discriminant is part of your quadratic formula. It's b squared minus 4ac. That part is what's underneath the radical. It's the radicand. It tells us how many zeros we might find. We might find 1 0, 2 zeros, or maybe it has no zeros at all. If our discriminant is greater than 0, so if it's a positive number under that radical, you're going to end up with 2 real solutions. If under the radical you get the value of 0, then there is only one solution. That means your quadratic curve there, your graph, is just sitting on top of the x-axis, touching it once rather than touching it twice. And if under the radical you get a negative number, so a negative radical, we should know that that's not possible right now in our lessons, and it's an imaginary number that we get, and therefore there's no x-intercepts. So we would have no solutions for that. It says determine the number of types of solutions that the quadratic will have using just the discriminant, which is that b squared minus 4ac. So our first one we're going to rewrite so we can see what a, b, and c is. We're going to take b squared and minus 4a and c. 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times negative 2 is a positive 8. 9 plus 8 is 17. Therefore, we're going to get 2 solutions because our discriminant is positive. Oh my goodness, look at this next one. We've got some solving to do. So I've got 25x squared. I'm going to subtract 12x on both sides. And I'll get negative 30x. And I'm going to add 9 to both sides so that my equation is equal to 0. I'm going to take my discriminant here, which is b squared minus 4 times a times c. 30 squared is 900. Negative 4 times 25 is going to be negative 100. Times 9 would be negative 900. 900 minus 900 is 0, which leads me to 1 solution. Under the discriminant, we've got a value of 0. Last one, we just make this f of x part 0. So again, I'm typing in my b, squaring it, minus 4 times a and c. Negative 5 squared is a positive 25. Then we have negative 4 times negative 3. That's positive 12. Times a negative 4 again. So positive 12 times a negative 4. It's going to give us a negative 48. And 25 minus 48 is negative 23. That's my discriminant. So that tells me there are no zeros, because the radical can't be a negative number to get real numbers. These numbers here are actually imaginary. And that takes care of our lesson on using the quadratic formula to solve. We just plug everything in and use our order of operations very carefully. The value under the radical sign is called the radicand, and that dictates how many zeros you will have. If the radicand is positive, you will have 2 zeros. If your radicand is 0, you will have 1 zero. And if your radicand is negative, then you will have no zeros.